Hello everyone, welcome back to my channel. Today I will explain how to use Matlab to implement transfer function and also introduce these functions. Let's enter the Matlab. First function tf. We can use tf to extract the transfer function's coefficients, and the numerator of the transfer function equals the coefficient of numerator is 4 and 8, so equals 4, 8. And the denominator equals the coefficient are 1, 2, minus 15, and 0. Don't forget 0. So the transfer function p equals tf, numerator and denominator. Run it. Note here, this is the result, same as the example. There also another way, use tf to build the transfer function. The Laplace factor s equals tf s. Define the Laplace factor s. So the transfer function equals p equals 4 times s plus 8 over s cubed plus 2 times s square minus 15 times s. Run it. Here is the transfer function. Okay, next function is zpk. Z means 0, 0 value of the transfer function. P means pole, and K is gain. So in this example, the 0, first let me comment this code. The 0 value K equals minus 2. Pole equals 0, 3, minus 5. K equals 4. The transfer function P equals zpk. zpk. Run it. This is the result, same as the example. Next, tfdata. Comment this code. The tfdata is to extract the coefficient of the transfer function. Let me copy this code. We define the transfer function, and we want to know the coefficient of numerator and denominator. So equals tfdata p. This is the result. If you want a clear result, we can insert v here. Run again. So the result is very clear. This is the coefficient of numerator for 8, and this is the coefficient of denominator. And next, zpk data. So obviously, zpk data can extract the 0 value, pole value, and the gain from the transfer function. So the zpk equals zpk data p, and run it. Here is the result, and if you want to have a clear result, insert v. So here is the result. The 0 value is minus 2, And the pole value is 0, -5, 3, and the gain is 4. Okay, let's go on. Next, pole 0 and t0. 0 and t0 are same. Obviously, pole means the calculated the pole value from the transfer function, and the 0 is 0 value, and t0 are same as 0. So let's try it. The pole p and 0 p and t0 p. Right. Okay, this is the result. First is the pole value 0, -5, and 3. And the 0 value is -2. And the t0 same as 0. Alright. The last one, roots. Roots means the solution of the transfer function. So if you give the coefficient of the numerator of the transfer function 4, 8, it can calculate the 0 value, -2. And if you give denominator coefficients 1, 2, -5, 15, and 0, right, this is the pole value of the denominator. Alright, that's all for today. I will be releasing a 4-part series on the basics of control engineering soon. See you in next one.